and welcome to the Robotics in Construction webinar. My name is Nicci Rossouw. I'm the CEO of Robotics Australia Group, and I will be hosting this talk today. We are the peak body for robotics in Australia, and our role is to advocate, connect, inform, and promote on behalf of the robotics community in Australia. We are a not-for-profit organisation, and our sponsors are Laing, Advanced Navigation, RSM Australia, and Vex Robotics. And of course, then we've got all our network members that support us as well. So thank you very much to everyone involved in our community and our growing community. I'd like to thank our panelists today, Greg Peters and Mark Pivac, for joining us. I know you've both got hectic schedules. So I think we're just going to kick off. To everyone that's joined us, you should have an option to put some questions and answers, or just put some questions below in the discussion. Greg, I think we're going to kick off with you. So please feel free to give a great introduction of yourself and what you do at Laing, and we look forward to your presentation.
Thanks, Nicci. So hello, everyone. My name is Greg Peters. So I'm the Field Robotics and Automation Lead at Laing. We sit within our Technology Innovation Group. It's good to be here. To set expectations, this is sort of a really short, compact version of a larger presentation I gave quite recently to sort of the engineering community about robotics and automation in construction. And I work in, I guess, what we call a tier 1 construction environment, which is sort of the big companies that build the mega projects, the infrastructure. So my lens on that is that, and less on, say residential construction. I'm assuming you can all see my screen, so I'm going to keep on going. So a few things I want to try to speed through today. Why construction and robotics need each other, the current state of our market as I see it, the challenges that we have in adopting robots as tier 1s at the infrastructure space, and why I think Australia is actually quite well positioned to capitalize on this. So those who don't know what Laing is, we're an international engineering construction company, sort of 6 billion revenue in Australia. We've been working for about 70 years now. We operate in the United Kingdom, Middle East, and Australia. And we focus on areas like rail and roads and the rail interface, so train stations, train lines, that sort of thing, as well as in defence and the renewables sector. So construction, for those that don't know, is massively important to Australia. 150 billion in direct value to the economy, and a further 300 billion through the supply chain, and about 1 million people equivalent FTE. So there's essentially no other industry that can create the same level of value to the nation as construction. And that's across all construction, including residential. So we're massive. But as an industry, we've got some real challenges that are no secret. So the pipeline of work, the booked amount of work is growing, and it's outstripping the workforce. And so we've got a supply-demand problem, effectively. And simultaneously, productivity is flatlined and to dramatic effect. So on the left is the wage growth versus productivity. When wage growth and productivity don't grow together, you've immediately got an issue. And when we look at data sets way back to 1950, industries like manufacturing, agriculture that have heavily adopted automation have grown at a productivity of 8, 10, 16x, while we've effectively stagnated. In fact, I think we've gone back by 1%. And this is actually funny because I look at the International Association for Automation and Robotics, which is an academic journal celebrating its 40th year. And in the very first issue in 1984, a Japanese author drew this graph on the left showing the exact same curve of the problems facing Japanese construction back then. So unfortunately, absolutely nothing has improved. So and just to paint a picture on that, because we're so large as an industry, if we had simply just kept up with the productivity rate of all other industry, Australia's productivity would have grown by 4.5%. So there's a tremendous reason for us to improve our productivity at the GDP and economy level. So current state of the market. So that's why we need robots effectively. Like there's all these other reasons, I guess, like safety, differing ways of work, capturing a larger pool of talents. So we want to be able to bring in different people. Construction just isn't big, strong blokes. So robotics offers a great opportunity there. So what's the current state? And so just to give some background, I'm going to assume most people on the call are roboticists. So this may be plainly obvious, but there's kind of 3 categories of robots in construction as I see it. Offsite manufacturing, they're your traditional robots. And I'll go through some examples of each of these. Field robotics, that's basically as soon as we let them out of the big factory. And then we have, I guess, situational awareness, or where the robot may not be a physically moving asset, but it meets all the other characteristics of sensing, acting, thinking, and critically, it's a moving goalpost. In some areas, very low-tech solutions are robots. In other areas, we're already going to very high-tech solutions to meet the definition of a robot, and the simplest would be a drone. Remote piloted drone is probably not a robot in the construction sense, but a fully autonomous drone doing activities is. So off-site manufacturing is frankly where a lot of the immediate opportunity still remains. This is Laing facility in the United Kingdom, which we built about 15 years ago, I believe. It's a highly automated and mechanized facility for building precast concrete. So just-in-time manufacturing of rebar, placement of all of that to a bespoke design, robotic dosing of concrete and mixing. Effectively, the whole high-speed carousel is fully automated. And then we blend that with a 70-60-30 ratio with manual labor as well. And what that gives us is a huge percentage, a 30% increase to our project delivery schedule, which is critically important. We're not alone in that. In the timber space, for instance, in the residential sector, Robotics is just opening their facility in Victoria, where they're trying to use traditional robotics automation to build agile elements for construction of timber trusses, walls, that kind of thing. So lots of applications to make mass manufacturing technology into sort of bespoke manufacturing technology in both the residential and sort of the mega stress sectors. Situational awareness, broad category. So I'll give some examples. Something like number plate recognition that then also digitizes all of the paperwork that goes along with that, and then maybe informs someone further on the site. So an example might be a truck arriving, it books them in, does all the logistics, verifies where they need to go, informs the site, tells them where to go, does a weighing of them, that sort of thing. Are all sort of emerging and mature applications in the construction sector. Throw in some IoT for tracking assets, throw in some machine learning to understand what is that asset doing to capture its productivity rate. These are all things that basically everyone is doing in some way. Other examples include machine vision like Blindsight. It's a camera that bolts onto heavy plant, that has image recognition, looks at people, and can do everything from alert a driver to actually stopping the machine intelligently. Build AI, another Australian company, where they take a camera that's on the hook, can use image recognition to look at what's on the hook and start to do analysis of the construction site to deliver not only safety, but actual productivity information. So that's situational awareness and automation. And then field robotics, which is the big one. Most people think of this when they think of construction, big yellow heavy plant. So this is from one of the Trimble's trade day a few years back now, where we had a range from teleoperated, autonomous, human robotic teaming, fully autonomous systems. Every trade show, they love to pull these things out. They are progressively getting more and more available. The cost is coming down. It's translating from the mining sector. But at the same point, we're still really not ready to have these on sites in general. And mainly it's not the tech, it's things like safety standards, workflow, and all the other things. And I'll get to that later. But we're at the point where you can buy a $60,000 bolt-on asset and convert a compactor into an autonomous compactor. Interesting one for the roboticists. So the UK recently created their connected autonomous plant levels. So Society of Automotive Engineers, you might be familiar with the idea of a Tesla. Is it a level 1, 2, 3, or 4 autonomous vehicle? They've come up with a new system, the OUDAR system, to rank all fleet based on its level of autonomy. And that's how they're going forward in the UK. No movement on something like that in Australia just yet. And then ultimately, I think fundamentally, are we going to go to the world of no driver's seat? And I think, frankly, we're a long way away from being able to do that, because these assets need to be able to work full time. And solving the general construction problem is much harder than solving a niche application. But at the same time, it's sort of not new. 2017, we took mining grade tech from ASI and put it on our water cuts. So, it's actually not very hard to make these things autonomous. It's very hard still to make them work autonomously day to day in a live construction environment. And construction is very different to mining. It is not a siloed environment. There are people everywhere. It's a dynamic environment. It's quite complex, and it's not an outdoor factory. It's also not alone. So this is a snapshot, and I won't have time to go through anywhere near the detail, but effectively, you think of the construction market. Any job you can do, there's a brand, mature or startup, somewhere in between, that are trying to tackle it. Some of my favorites, I won't go into this thing in the bottom left because we've got Mark who can talk about that in a moment, but 3D printing, as an example, in the infrastructure sector is behind in the residential sector. Large assets that have public infrastructure, where the struggle is not so much the tech, it's the standards compliance, the proof points, and getting the opportunity to apply it. And they're starting in the infrastructure sector with things like facades, stairs, sort of low risk assets. The more traditional things like robotic arm on wheels, you see everything from spray painting, hole drilling, using some kind of vertical access platform to solve both the productivity and access problem. And where we're starting to see real impact is where it fundamentally changes the build process. So instead of just trying to do it the way a person did it, if you can do it in a way that's superior, so on top right, not having to put scaffold in and put someone over a live edge, you can fundamentally speed up the design and build process and take away some of the clashes that we would normally see. There's a lot of, these are probably the most mature in the market. They're low cost, they're simple, they do a great job. GPS control, line marking, situations like that. They're sort of ubiquitous now in the market. And we're waiting to see what's next in this space. And then you've got your whole cattle of fish of ones that just don't fit into any nice sector. So things like load orientation systems, teleoperation systems, systems that fundamentally change the build, like the top left, where you actually have to factor it into the design from day one. And where we take something like a giant robotic arm and really carve out, in this case, it's utility excavation and a robot that can do 90 to 100% of the job, but it's a niched asset. Drones, we won't go into it, but others say we use it for both image recognition, surveying, and now in the build, one of my favorites, bottom right, it's actually being used to install power lines. Instead of sending people up, it's running the lines across large gullies. And then you've got swarm robotics and rail-specific robotics that are developing in what is already highly automated industries of rail and tunnel boring. So what I get at is, like, there's a huge amount of stuff going on, but at the same time, if you come onto almost any construction site in Australia, you're probably not going to see any of it, or you might see one or two things on one day. And this is my view on why. So construction has a high TRL, so technology readiness level. We need it to come to site effectively ready. And that's really hard if you're trying to develop a solution. And this is why. Effectively, the time and cost pressures are extremely tight. We do not have time to experiment because we don't build the building twice. We build it once. And you don't get to make a mistake. The cost of mistake is very high. And the insurance liability of that mistake showing up 10 years in time is massive. Right? So you see all this stuff around buildings with cracks or defects 10 years later and businesses folding and people being left out. That's a problem. So we need to have something that is basically bulletproof and proven. And as a result, our risk appetite is extremely low. And then when you factor in that for mega projects, we might have planned down to every day's productivity years and years in advance, it's extremely hard to inject some new novel technology last minute. We have a customer. In most cases, for me, it's the government, and the government's government funding. It's your taxpayer dollars. We need to convince them that this is a good use of the taxpayer dollars. So do you want your train station to help the robotics ecosystem by testing a new tech, or do you want your train station delivered on time and on budget, right? Then it doesn't have to be A or B, but that's a big part of the conversation. Obviously, safety, massive driver for us, but also it's... robots can actually create more safety challenges. We need to be able to make it so that we can do both together. So that's human robotic teaming, I think, is going to be a big part of this. But we also need to consider the ethics, right? So people are a big part of this. Robots are always problematic around taking jobs. We need to weigh find ways to make the messaging done right and work with the people. And also we need this robotic supply chain to have the skills to maintain, to fix these things. This thing needs to work every day. We can't then wait 6 months for a part. And then actually, every time I go to a construction site, I look for repetition. And honestly, in our sector, actually, when you zoom in, it's not actually repetitious at all. And that's really hard for a roboticist, right? And then we don't actually have the level of detail you might think, because our skilled trades know what they're doing. So we can give them a finished drawing and we don't need to model every single little detail. And then finally, do you integrate with existing process or fundamentally change the process, which I guess Mark will touch on. If you're going to fundamentally change the process, that's really hard to mature because now you're really risking high risk, high reward. How do you get that in at the experimental phase? So why Australia? Well, because we're awesome, but also because we have the mining sector, the agriculture sector that have huge amounts of the talent pool in this space. Most of the mining automation technology integration capability comes from Australia. So we're well positioned from a skill set to actually do this. We have amazing academic sector that's focusing on those areas, as well as well-funded university and industry collaborations that target these initiatives. And hot off the press, we've hosted in partnership with Robotics Australia Group just last week, the very first Australian Construction Robotics Forum, where we've taken members of this ACA, so the Tier 1 constructors, together to start coming up with a collaborative approach to how we can do this. And it was really refreshing to see the conversations that evolved. We won't go into them yet. We'll release something in the coming weeks. But we understand that we need to work on this together. We can't do it alone. It's encouraging to see that at a government level, there's a strategic approach to this. And I think that's another one. We need to find ways to solve all those problems at a policy level, particularly where it's government infrastructure led. And we need to do this in a strategic way, right? So that we're not all competing with each other at the fundamental level. We need to find ways to move on as an industry. So like in summary, I haven't actually given you a solution to any of my problems, just some ways we're trying to solve the problem, right? But we are a giant industry. We desperately need solutions. Collectively, I think Australia actually has all of the capability to do it. Solving this problem at a GDP level is worth doing, and it will create exportable sovereign capability, which is a high priority for government. So it's over to the robotics community to come to us, reach out through RAG, contact me on LinkedIn. I can give you a steer to our new Robotics Construction Forum group to help you understand what our needs are, to help you better understand what's going to actually be an adoptable technology, and help for us to articulate to you what problems we actually have and what you should solve. And I think that's probably the first step, and probably all I have time to cover today.
Greg, thank you very much for your excellent presentations. We don't have any questions that have showed up at the Q&A at this stage, but to our audience, you've solved all your problems. They've got all the information. Greg was actually on my podcast, so if you're interested in more of his nuggets of wisdom, please listen to that. And Mark actually will be released next week. So I've just got all these podcasters and people contributing. Mark, I think we'll go on to you, and then afterwards we can open it up, and there is a question, but if you want to get your presentation up so long. Greg, do you think that defense shipbuilding would be a step towards construction robotics?
So what was the friendship building? Was that the
defense shipbuilding would be a step? Yeah.
Yeah, I mean, it's obviously a sector we actually play in. We build defense facilities. I'd say one of the challenges with the defense projects is the same that faces the rest of the industry, is it's balance of dollars, right? So defense in theory love high-tech solutions, but at the same time, when it comes to building their assets, they're under the same pressures. So we look forward to what opportunities come out of that. It's really interesting to see how some of the startups in the ecosystem get their first leg in the door through these defense projects and programs. But I haven't yet, I guess, seen it translate to defense bases being built. But I've seen some really interesting things in the US where, for instance, they are looking at how you could use automation to establish an Air Force base at high speed in a very high risk environment, right? Potentially under combat. Not sure I've seen that level of expenditure at an R&D level in Australia yet, but if you know someone who can make it happen, let's do it.
Colin, does that answer your question? You can just fire away, type, or add to it more. So Mark, with that, I'm going to open the floor to you. And if you'd like to do an introduction and just tell us a little bit about yourself, and then go for it.
Yeah, thanks, Nicci, and fantastic presentation there, Greg. You're a hard act to follow, but really laid a lot of the groundwork for the sort of general robotic situation. And what I'll be talking about is our more specific solution for one part of that massive construction industry. And one of the things which Greg really touched on is just how massive the construction industry is. And I was drawn to it because I developed technology for roboticizing some automation issues, which really didn't have a market until 2005, when there was a building boom on in Western Australia, and the price of bricklaying went through the roof, and there was a massive scarcity of bricklayers, and that's when I kind of came up with the concept that, wow, that technology could really be applied to this, and maybe there's a solution lying there. So I'm the CTO of an ASX listed company called FBR, which used to be Fast Brick Robotics. We employ just over 100 people here in Western Australia. We've been listed since 2015, but the actual project or the concept for this started a lot further back, and really sort of the very first genesis of it was back in about 1991, when my father, who's a mining surveyor, was working for Alcoa, and they were just starting to look at how they could automate certain parts of their mining operation. And I came up with a few concepts back then, which were never implemented. But fortunately, I can say that, you know, over the coming years, some of those dreams have come true, and Alcoa has, you know, really automated a whole bunch of different things in their mining operation, as have most of the miners in Western Australia. We at FBR chose to get into the residential construction industry because, unlike the commercial industry, which Greg sort of pointed out, is, you know, there's not a lot of repetition there because there's so many different things which have to happen, and so many different things happening at the same time. Fortunately, bricklaying is one part of the residential construction process where there's nothing else usually going on site. And particularly with the speed that we can do that, we can take a 2 to 6 week manual bricklaying process and do that now in a day. So we can have complete control of the site, which makes introducing robots onto the site a lot easier, when you don't have to worry about other people, and particularly people outside of your company being on site. So that was sort of one of the main reasons that I chose residential construction, along with it being an absolutely massive market. You know, it's right up there. If you look at it globally, it's in the trillions of dollars sort of realm, which means there's, you know, potentially a massive market for us to expand into. And this hasn't been a cheap process to develop this technology. You know, we've spent over $200 million on getting this to the stage where it's commercial. So, you know, don't be under any illusions that this can be done cheap. You know, I've always been a very commercially focused engineer. Somewhat naively, when I started this, I thought I'd have a robotic bricklaying machine up and running in about a year for a couple of $1 million. And we kind of did. But what the construction industry needs is a 100% solution. You know, 80%, 90%, even 95%, even 99% is not good enough. You have to have an absolute 100% solution that addresses everything. Every single thing that the builder's concerned about, that the customer's concerned about, has to be worked out. And it doesn't all have to be robotic. You know, we still do some things manually on site because we haven't got the robotics technology to that point yet. But we are extremely automated, and I would say that of all the robotic construction systems or processes or robots that are out there in the market now, and Greg showed a whole range of them. I would say that end to end, we are the most automated. We basically rely on a human to load a pack of bricks in the back of Hadrian, and from there on, it's completely automated, where we cut the bricks, we transport them out. We have humans to do a bit of initial surveying of the slab and the site, so we know where that is. We think that will eventually get automated by scanning and so on, but that's not cost effective at the moment. And then the complete construction or the laying of the bricks is completely automated. Now, one of the big challenges is introducing automation into an industry which has been traditionally very non-automated. And because you need to bring in 100% solution, we decided that the best way to do that was to actually work in with the existing residential ecosystem, where builders nowadays are essentially contract managers. They use a huge number of subcontractors. Some builders do employ various trades, but even within their organisation, because each house itself only needs those trades for each specific trade for a fairly short amount of time, those trades actually move around sites quite a lot, unlike, say, the commercial site where you might have, say, a steel fixing team who's doing, rebar reinforcement. They're basically doing the same job for, say, the building site might be on a 2-week cycle to pour a floor, and if it's 26 floors, they'll be there for a year installing steel on the same building site, basically doing the same job every 2 weeks as the floors go up. Whereas on a building site, a floor tiler will come in and tile a house in a couple of days, and then his next job will be somewhere else. Might be next door, might be in a completely different suburb. So we actually fit into that ecosystem. We provide what's called wall as a service. So the builder doesn't need to think about buying a robot, learning how to operate a robot, how to train people, how that's going to impact in their safety documents and all that sort of their safety procedures. And really, builders aren't that interested in operating a robot. At the end of the day, they just want walls installed. And that's what we do. We provide walls as a service. So to roll that out globally, we've partnered with leading industry participants. The most amenable for us to work with have been brick and block manufacturers. And we've recently signed a set of agreements with CRH Ventures, which is a venture capital arm of CRH, which is about a $40-odd billion company in the US, and well, they're actually global now. But they provide a lot of building materials, from aggregate all the way through to bricks and blocks and a whole range of other stuff. Our next step is to do a 5 to 10 home demonstration program in Florida. And after that, we hope to execute a JV where we've already worked through all the documentation for that. And we've already built houses, so we don't see any real problems with that. And that will eventually lead to about a pipeline to have about 300 of these construction robots in the US. Just to give you an idea of the size of the market in the US, the underbuild in Florida at the moment is massive, and nationwide they build well over 1 million houses a year. So these are big issues that need to be solved on a global scale. So Greg touched on the rationale for industry adoption of robots. And, we've basically come to the same conclusion that the construction industry is really lagging a lot of other industries. And there's good reason for that. It's the complexity, it's the value of the projects, it's the difficulty of introducing all of this stuff. What I will say is that things which appeared to be very difficult to automate even just a few years ago, with the emergence of artificial intelligence, we're going to see a huge number of things get automated over the next few years. You know, when I first started my university degree, you know, the concept of having speech recognition was, you know, just being worked on, and people thought it would never happen. You know, even optical character recognition, people thought it would, you know, it wasn't going to be viable and that humans would have to proofread everything that was, you know, put into a computer. But we see now, you know, things which you know were inconceivable just a few years ago are automated. You know, who would have thought that a computer could write a document, you know, as well or better than what most people can? So just coming back to this slide, because I went a little bit off track there. The whole part of the wall of the service is it provides builders with certainty on their timing, and also the accuracy of the construction enables the building process to start to happen in parallel. One of the issues with building particularly in Western Australia, is that it's a very serial process where each trade basically comes in and fixes up the mistakes and the errors and the inaccuracy of the trade beforehand. That's not to say that each trade's bad at their job, it's just how it is. You know, guys set up formwork for concrete and the formwork might not have been laid out exactly right, or it may have moved a bit during the pour, particularly on a residential site. Hopefully you don't get that so much on your sites, Greg. But then the bricklayers will come along and they'll just build to whatever the slab was, however the slab was laid. And then the roof guys will come in and put the roof on, you know, however the walls were built. You know, there might be a wall that's could be 100 mil out of position, and they'll just build around that and not worry about it. What that does mean, though, is that it's a very serial process, because it's very difficult to make things in parallel if you don't actually know what your thing has to interface against. And this has been the big difference between construction and general manufacturing automation. You know, in factory automation, where it's all very precise, you can build stuff in different factories, have it all come together and be assembled. We're not in modern mass manufacture, we're not sort of building each component based on the inaccuracy of the previous components. We're building all of them to a tolerance so that when they're brought together, they can be assembled. And this is one of the big areas which builders here are sort of dreaming about, but haven't sort of got into implementing, partly because apart from in modular construction, where those parts are built in factories and do go together well, with the site-based construction, it's not a concept that they're really very comfortable with, because they're so used to dealing with those inaccuracies and that serial nature of production. One of the big factors is a reduction in site waste. So typically in a manual building process, there's a 10% allowance made for broken bricks and bricklayers just discarding sort of up to 10% of the bricks which they cut and so on. We actually know exactly what's going to go into the build down to the very last brick. And we also know how all those cuts will be used so that we can use offcuts rather than just throwing them away or having them broken. Massive improvement in safety. We do have the challenge of having a robot on site. So I think Greg mentioned Blindsight, which is one of their sort of innovations which has been spun out, and where we have some of those units which we're trialling. But by and large, the big construction injury factors are repetitive strain injury and things from injuries, you know, around the manual handling areas of lifting, pushing, pulling, bending, all that sort of thing. And I've got a few numbers there. You know, 35% of workplace injuries are due to lifting, pushing, pulling, you know, and repetitive movements like that. And the construction industry itself has the highest injury occurrence in men, accounting for 17% of workplace injuries. So it's a lot of opportunity to improve there. When the heavy lifting is done by automation or robots or machinery, you've really got the chance to reduce that. But that needs to be carefully managed, because now you've got mechanical equipment and robots, you know, which do have the potential to injure people if they're not guarded or managed properly. And then, of course, all of that, the speed, the accuracy, the safety, and the waste reduction leads to a lower cost per brick laid and a much faster project completion time. So the benefits of Hadrian X. And look, if anybody, I'm not going to show any videos today, but on our website, and there'll be a link at the end of it, we've got plenty of video on our website, and you can actually see these Hadrians out in operation in Western Australia, out on real building sites. We're the only solution that's fully mobile. We're truck mounted, so we can turn up on site. We put our outriggers down, we unfold our boom and survey the slab, and we're ready to go. So unlike a lot of the 3D printing printers, there's no gantry set up. We have a minimal site footprint. Hadrian's designed so that we can park on the road and build the typical long, skinny 4x2 house, which is built not just in Western Australia, but it's fairly typical in Florida. Their blocks are, surprisingly, in the US, they seem to have a lot more building land available, and their blocks aren't typically as tight as they are here in Western Australia. We're building on blocks that are as small as 130 square metres now here in Western Australia, which is, it's sort of, you'd think that kind of block size you'd associate with London and Tokyo, but just the shortage of land over here in WA has sort of led to that. Speed and accuracy, because we're fully autonomous, robots don't need lunch breaks and that sort of thing, so they just keep working and don't get tired and don't need a drink. And we can also deal with much larger blocks than what manual block layers can. We can be 20 to 40 times faster than a manual bricklayer. So instead of being on site for sort of 2 to 6 weeks, which is typical for bricklaying in the residential construction industry, we can be out in and out in 1 or 2 days. Significant cost efficiencies over traditional building. All of those things which I've talked about, result in big cost savings. And of course, we're limited here in Western Australia to just building during daylight hours, but many other parts of the world, robots are quite happy to work 24 hours a day, 7 days a week. And in most factories they do, and we see no reason other than, influences on neighbours and so on, that we shouldn't be able to do that with robots on the construction site. So a big aspect of what we're looking at is, improving sustainability in construction. Construction's a massive user of materials, and we think that, reducing the waste impact is very important. There's also a lot of other impacts by going robotic, which you don't sort of think about, but if you have a team of bricklayers that's driving out to a building site 20 times and there's 3 bricklayers, that's 60 trips to the site. So there's all that fuel and car use, which is reduced when you go robotic. Sure, you're taking a big machine out, but it's only going out there once with the one crew. So there's potentially a lot of intangible benefits which can really sort of have a big impact on the overall cost, but also on the greenhouse emissions once you start to fully account for all the things which are going on. Mentioned earlier on, safety. One of the big issues in the building industry at the moment is silica dust, because it's all robotic and handled in properly guarded and extracted or water fed cutting. We don't have that same dust problem that can happen on site, particularly in the residential construction industry. So this here will give you a little bit of a history of what we've done and what's involved in getting a robotic project from a concept through to something that's actually usable on site. As I said, the project really started in sort of 2005, and this first Hadrian X, we started building that in about 2006, I think it was. We almost got it working by 2008, then there was a global financial crisis which slowed everything down. I managed to keep it alive through my engineering business. And then we listed and got funded properly in 2015. So that first Hadrian we built on top of an excavator, mainly because excavators are really convenient machines to modify. You get a lot of stuff, you get a lot of bang for your buck with an excavator, and they're just a really nice platform to build things on. But we knew that that wouldn't be commercially viable in all the different markets. And for the residential construction industry, particularly in Australia, you really need something that can mobilise quickly and go from site to site. In the US, something like Hadrian, the 105 model on the excavator could probably work. They quite often over there build out a complete suburb that's owned by one builder, and they might be building hundreds or even 1,000 houses in one suburb, in which case, you know, an excavator or track-mounted vehicle you could deploy out there and leave it there for, you know, weeks, months, or even years as it gradually moves around the suburb, building the whole thing. But that just doesn't work in Western Australia, at least, and really not across Australia. Typically, house lots are sold either to individual customers who have their own builder or to a variety of builders, and it's not unusual for, say, 10 houses in a street to be built by 5 or 6 different builders. And they'll all be on a different time schedule and not sort of sequenced in with each other. So you really need a mobile and very agile construction system. So part of our listing was to come up with a more commercially viable Hadrian machine, which we did with the 109, and that's what we've been using. That's our first machine there, which we've been using in Western Australia to prove out the commercial viability of what we're doing. And we've built quite a few different houses and commercial buildings, townhouses, and really been trying to spread out and show the versatility of what robotic construction can do for the residential industry. Our next generation machine is bigger, better, faster, all that sort of thing, much more commercial, handles blocks that are even twice the size of Hadrian X. So we'll be able to handle blocks in that machine which are equivalent to 24 standard house bricks. So every laying motion is like a bricklayer laying 24 standard bricks or 12 maxi type bricks. And what's really significant is off the back of all these demonstrations and so on, we've had a lot of global interest, and we're now ready to deploy into the US with our first demonstration machines, which we expect will lead into a much sort of longer commercial thing. Along the way, we've developed a massive IP portfolio. We've got 34 different patent families with 200 different applications and 90 design applications, a lot of trademark stuff as well across that. And the core technology that we have is what we call dynamic stabilization technology. So what this enables is a very long and fairly flexible boom to support a robot, which can then do very accurate work. The other way of tackling robotic accuracy is to build something really rigid and very stiff and very precise, which usually means very heavy and also very large in comparison to what you want to work on. At the other extreme, you know, you have things like construction cranes or concrete pumping booms, which don't have to do very precise work. You know, the final manipulation on most cranes or concrete pumps is done by a human hanging onto a hose or, you know, pulling on a load with a piece of rope to get it all lined up perfectly. So what we have is a measurement system which measures where the end of the boom is very fast in real time, and we calculate a correction which the robot on the end has to apply so that the end effector of the robot ends up in exactly the right place. Now, we chose bricks and blocks because it's a very repetitive process, mass customization, speed of construction with blocks is very good, and it's with a material that is well proven and well known around the world and trusted by builders. So the end product is not that different to what they would get from a manual builder. And we do use a construction adhesive in place of mortar, but in Europe they've been doing that for nearly 20 years now. So that in itself is a well-proven technology as well. We've, over the last few years, done a few different demonstrations to show that DST is applicable to more than just bricklaying. For example, we've done simulated 3D printing, and we think that this kind of technology could be fairly easily integrated into 3D printing machines, which would get them away from having to construct a machine that's bigger than the house with a gantry style. So plenty of opportunity there in the future as well. We also have developed our own software, which speeds up the planning process. So from plans, and the little picture down on the left there is how our CAD software works. We can basically import or scan either a paper drawing or import a PDF of a building plan, or import a 3D model. But typically residential builders don't have a lot of 3D models. So we typically find we have to work off 2D PDF CAD drawings. And we've got tools in that software which quickly populate the walls and put in the windows and doors and lintel details and all that sort of thing. And then work out exactly where every brick and block has to go and how they all mate together and how the intersections work and all that sort of thing is done quite automated now. And then that creates a database which drives Hadrian out on site. So here's a slide on our US market entry, and that little picture down on the left there of a US subdivision is just typical of what you see. What you don't see there is that, rinse and repeat, that goes on as far as the eye can see. Massive construction there. So our next phase, as I mentioned before, is a 5 to 10 house demonstration program in Florida. Upon successfully completing that, we hope to execute a JV, and that JV will be operating wall as a service using CRH bricks and blocks and supplying to American builders who want to use the service. And together we think there's a market for way more than what we've initially set up for. But the initial purchase order will be for 20 Hadrian X's and a pathway to 300 over time. And CRH is putting in the financing to finance those Hadrian X's inside the JV. So we're initially setting up in Florida. There's a lot of good reasons to do that. Very big market, very growth orientated. The builders are already on a really good sort of tight time frame construction wise. They typically build a house in 90 days from site works to completion, which is almost unheard of here in Australia. And what that means is that even a 5 or 10 day time reduction is fairly significant to them, whereas on the 1 to 2 year build cycle that we have in Australia, 5 to 10 day improvement in construction time is not seen as being that significant. So I'll open it up for questions.
Great, thank you very much for a fantastic presentation. Greg, I think this one was aimed at you just on the end of your presentation. Obtaining compliance, e.g. ACMA and Australian standards approval can be a lengthy and expensive process, especially for startup companies. Do you have any suggestions for streamlining this process? And that's Mark Clarkson asking that.
I think Mark can definitely answer some of that too. I think from my understanding, the answer, I agree. And if anything, the lack of the appropriate standard is sometimes more of the challenge too. So I used to work in a robotics startup where we were one of the first, I guess, of these field robotics applications, and we were stuck between two standards: the industrial robotics standard, which was completely inappropriate, designed for factories, and human safe robots, which are designed to carry at the time 5-6 kilograms. Then there was nothing in between. And we ended up going to people like Pills Safety to get it audited, and they had no real understanding of the topic space either. So it's a minefield of understanding what is needed to be done. And I think as an industry, we don't know, and that actually builds to our risk portfolio, and it sort of scared us away a bit. Maybe Mark, you might have something similar.
Yeah, we've experienced exactly the same thing. And, it's not just standard in the safety side of things. You look at Hadrian and you go, well, what do we build this thing to? There's specific standards for cranes and concrete pumps, and we're not a crane and we're not a concrete pump, and sometimes those things conflict with each other, so we've just kind of had to go it alone. And, we sort of reference those standards where we think they're helpful or useful. And then, on the safety side of things, Greg's exactly right. A construction site is not like a factory. You can't easily put, 100% guarding around something when humans have to do tasks which, your robots also doing. So you've got to come up with other ways of doing it. And then, as the question asker pointed out, to certify safety systems is really difficult because the bar's set really high, and the levels of reliability are also based. These standards started years ago. Back when the technology wasn't there, and so they're written around things like redundancy and determinism, and how do you incorporate artificial intelligence into something when the standard says that it has to be deterministic? The intelligence is not deterministic. You could ask me the same question on 2 different days. I'm an intelligent person. I'll give you 2 different answers. The safety standards expect that if you ask the safety supervising PLC the same question on 2 different days, you're going to get exactly the same answer, and you would hope so because people's lives depend on it. So what typically happens is that you look at the standards and what's required, and then you go, well, how can I work with that and benefit from that and use this new technology rather than perhaps the be all and end all, but as an aid to something. And I think, there's a lot of devices out there which, dramatically improve safety, but they're not actually certified as a safety device. But you can use them as an aid to the operator. So, one of the big things is that if a machine is manually controlled, by a person, they have some kind of safety responsibility for that. And then what we're finding is that, you can really aid that with artificial intelligence, which, is difficult to certify, but has a fantastic concentration, and they can aid the human operator, who is already allowed to do a process, but can have lapses of concentration or trying to shortcut the system or something like that. So I think you've just got to take it on a case-by-case basis, and really think about it, do your risk assessments and all that sort of thing, and see how you can use this new technology together with humans or in your process to get around it. And, there's no shortcuts to getting certification. I mentioned earlier on that, we're using brick and block because it is a well-known material. All we wanted to do was change the kind of glue that was used. It's already a construction adhesive used in a different area of construction. Other companies overseas are already using construction adhesives to bond bricks together. But, it's been typically an 18-month process, very expensive, with external agencies to do accelerated aging tests and, all the strength tests and all that sort of thing on our construction adhesive. So very expensive process, but then once you've done it, that becomes one of your competitive advantages. It's something that you own. We own that use of that material and its certification. And anybody else who wants to enter the market would have to go through that same process.
Mark, we've got
you can use it to your advantage.
sorry, we've got 3 more questions that I think are directed at you, and we've got 5 minutes, so you're going to need to blitz through them.
Oh, okay. I'll
yeah, no, I'll just crack the whip here. Colin asks, has the installation of retaining walls been automated, example along highways, etc.? It seems simpler than houses.
Yeah, it's one of the markets that we'd be really interested in, and also replacing tilt panel in a lot of commercial applications. We see there's a lot of concrete panels, used on big commercial sites, which are essentially, formwork for more structural concrete that's cast behind them, bridge abutments and all that sort of thing. We think there'd be a huge application for that. But, there's barriers to entry, which Greg outlined. A lot of these projects have been planned, years in advance. And it's kind of a chicken and the egg thing, until you've done 20 kilometres of, freeway sound wall. How can somebody like Laing O'Rourke go in confident, knowing that, the process that you're proposing is going to be good? They're going to say, well, show me 20 k's where 20 kilometres of wall, or a kilometre even, or even 100 metres against a freeway where you've done it. So yeah, we'll probably enter that market one day. But I imagine what we'll have to do is buy a patch of land somewhere and put down a fake road and build a wall around it just to show it can be done.
Greg, you've got...
On some of our townhouse sites, the one in Willagee, we actually did build quite a few structural retaining walls. That was on a sloping site, and there were retaining walls involved in that, and they were all done robotically.
Greg, you've got your hand up for a question.
Yeah, it's great that I understand all the reasons why, Mark, you want to go into the US. Why are 8 or so lucky people able to have an FBR house, and what's holding you back in the Australian market? Why do we need to jump to the US market for scale? And what's I see this problem all the time. What's holding you back in Australia? Yeah,
look, some things are easier to do at scale than to do individually. There's a number of issues in the Australian industry. One of them is just the willingness of builders to change over to robotic construction. And once again, this is kind of a chicken and the egg thing. A lot of the builders we talk to say, yes, we'd change over if you could do most of our bricklaying. But to do that, you're going to need 20 machines. Where's my 20 machines? And we're going, okay, well, we can't build 20 machines until we have orders, for the houses, and that's what's happened in the US. They're more committed to it. You saw those numbers there. They've committed 40 million US to purchase the first 20 machines, and that'll just keep rolling over. And part of the first, purchase order batch is for 300. They're conditional on being utilised, but they're committed to it. They're very keen to do it, and we just don't have that level of commitment here in Australia. People just don't understand the size of the market here in Australia.
Greg, does that answer your question?
Yeah, it's unfortunately I kind of knew the answer coming, right? Like it's like I've seen in the 3D printing space, the scale. So people like Icon, building 100 suburb houses that are 3D printed, and all the same challenges you talk about around that seems to be not enough proof point to then spin it up and do it here. And we see the same with just slightly tweaking a concrete mix to make it more sustainable, right? There's just this fundamental blocker, and it's just such a shame to see that it's a rinse and repeat cycle of, it proves our point that you do it here and you can export it as tech. And it's great, Australia's a great place to do it, but it's a shame that we then sort of start to lose all the benefits, and wish we could find ways to make it easier.
Yeah, well, I would love to be doing it, more in Australia. But here from Perth, it's nearly as difficult to go to, say, Melbourne or Sydney as it is to go to Florida. And, yeah, we're building quite a bit here in Western Australia. I think we're up to about 32 structures or something now. So it's quite a few more than 8 people, but it's certainly a lot shy of the tens of thousands of houses underbuild that we've got. We'd love to see a bit of government support from that. The government's always talking about how we're so underbuilt on housing and how they want to stimulate it. They quite often stimulate it on the supply side without thinking about they stimulate it on the demand side, by first home buyers, incentive packages, and all that sort of thing. But really, to fix most of these issues, and it's not just in the construction industry, it's the health industry or the education industry or whatever. You really, to get to service the market, you need to fix it on the supply side. You need more construction workers, which we can't get. Okay, so let's do it with robots. We've got the robots here, but there hasn't been as much support for that as what we think the industry really justifies.
Mark, we've got a bit of a chewy question here and we're running a little bit over time, so I'll fully understand if people have to drop off. FBR's heavily protected outdoor dynamic stabilization patent for robotic arm has been copied by US 3D printing firm Icon. Can Mark Pivac please respond?
Yeah, well, that's something we're looking at.
Colin Thomas, where will the next Hadrian's build be built?
Sorry, the next Hadrian's?
Yeah.
Yeah, the machines themselves are built here in High Wycombe. We have a global supply chain, so we bring in motors and electronics, from all over the world, hydraulics, all that sort of thing. But the actual machines themselves, all the structure, all the steel work, aluminium work, composite work is all done here in Western Australia, and we assemble them here. The US market, we're looking at how we can assemble on site, or sorry, in country, just through some of the the issues of dealing with trucks in an international market. We can't use the Australian standard of truck in the US, so we have to buy US trucks, and kind of doesn't make a lot of sense to buy a US truck, ship it over to Australia to fit a Hadrian on it, and then take it all the way back to the US. So we're looking at how we can do that kind of assembly work in the US. But I'm fairly patriotic and keen to keep it in Australia. But that said, there's massive incentives in the US, between the Inflation Reduction Act and all the various state incentives to build manufacturing, and particularly high-tech manufacturing in the US. There's some incentives in Australia, but as a business, you've just really got to look at it commercially. I think there'll always be a lot of R&D done in Australia and low rate production. But when you start talking about tens of thousands or hundreds of thousands of robots, you really got to start looking at a global manufacturing base for that.
Definitely. Thank you very much. I'm mindful of the time. Greg and Mark, thank you very much for joining us today. I think this could have gone on far longer, and I'm sort of pushing to an end. I think we'll have another webinar and we'll touch on some of these other topics that you've raised here. So to everyone joining us today, thank you very much for being here. If you haven't already followed or connected with Greg and Mark on LinkedIn, please do so now. I think they'd love to hear from you. And if you've got any other questions that we haven't been able to address in this webinar today, I'm sure they'll be more than happy to chat to you. So with this, thank you very much to you both for your time. And I look forward to seeing you soon.
Thanks, everyone.
Thank you, Nicci.
Thank you. Thank you very much for everyone for joining us. Have a great day.